Okay, so what we have here is a line that normally we could say, let's write an equation for this line and use slope-intercept form, which we did last time, which is using the slope, how much do you rise and run to get from one point to another? We rise 1, 2, 3, 4, 5, 6, 7, and we run 3, 1, 2, 3. So 7 over 3 would be our slope. But the difficulty with this is that we don't have a clear y-intercept. It's not right on an integer value. And so any number that we would put there would be some approximation. And therefore, if we used it to calculate some unknown point, it would be an approximation and not an exact value. So what we're going to learn today is how to use two different points and not the y-intercept to be able to write an equation for the line that will precisely calculate any particular other coordinate if we know one of the coordinates provided. Okay, so we're going to understand this better as we do some example problems, but here's the basic idea, is that you can use the slope of a line and then some point that you know is on the line, and you can use it to write and graph the equation of the line, okay? And any equation, any two equations for the same line are equivalent, meaning in this particular case, it doesn't matter which point we use, as long as we have the slope and one of the points that we know is on the line. We'll be able to write an equation in point-slope form. So what is point-slope form? And by the way, notice point-slope form, the name comes from the fact that you know a point and you know the slope, okay? This is point-slope form, okay? It's a non-vertical line, so we have a number for the slope, right? And it goes through this point, which we'll call it the first point that we've got, or whatever is x1 and y1. So in this particular equation, and this is what you want to write down, y minus y1 equals m parentheses x minus x1. The y1 and the x1, as well as the slope, are the things that will get replaced. You will notice that in the proper form, this original y is always going to stay where it is, and so is this original x that doesn't have the number subscript on it, okay? So y minus y1 equals m parentheses x minus x1, where the y coordinate of the point you know goes there, the x coordinate of the point that you know goes there, and the slope goes there, okay? So if you know the coordinates of this point, and you can calculate the rise and the run, then you have enough. And by the way, notice this. If we were to take this original definition of slope, which is y2 minus y1 over x2 minus x1 is equal to m, and we have that written here, and then we say, let's take the amount x minus x1 and multiply both sides by it. Whatever this is going to be the exact same thing. Okay, so we multiply both sides, that cancels out the bottom. X minus x1 on the bottom cancels out x minus x1 here, leaving you with y minus y1. And then m times x minus x1. So that's how you can go from here, and you can just switch it into this form. That's less how we got there, and it just demonstrates that it works. Okay, so the big takeaway here is that if you know a point and you know the slope, you can write an equation in this form. Or if you know 2 points, you can calculate the slope, because we know how to calculate the slope from 2 points. We see this down here. And then we could use one of them and the slope we found to write this form. Let's try this. So we're going to write an equation first. And they say it passes through this point, negative 3 comma 6. We have an x1 coordinate and a y1 coordinate. And as a slope of negative 5, what's the equation? Well, this is what it looks like. Okay, since you know the slope and a point, you can use point slope form, which is this. Now we know that this is the x coordinate, negative 3, so we put it there. Notice you're already subtracting that amount. So you're subtracting a negative 3. And that's what you see here. And so the parentheses becomes brackets so that you can put parentheses inside. Okay, y minus the y1 coordinate, or y minus 6, equals the slope of negative 5 times brackets x minus a negative 3, which we can then resolve this from a minus a negative 3 to a plus 3, because subtracting a negative is the same as adding a positive. Okay, and you get for this equation y minus 6 equals negative 5 parentheses x plus 3. I'm going to point something out here that's worth noticing now. Since you're always subtracting the y coordinate and the x coordinate, what that's going to do is take the negative of, or the opposite of, whatever the actual y coordinate of the point was. That'll take the opposite of whatever the actual x coordinate is. So if here you see x plus 3, we know that we actually subtracted a negative 3, and that's what the point's x coordinate is. Here, when you see a negative 6, that's because it was subtracting a positive 6, which is what the y coordinate of the point was. So if you were given an equation like this, and they said what point was used, well, to find the x coordinate, we would always do the opposite of what we see following that x coordinate. So since we see a positive 3 here, we would know that we had a negative 3 as the x coordinate. And since we see a negative 6 here, we know that we had a positive 6 here for that point. Okay, it's always going to appear as the opposite of what it is. And then, of course, the slope is the slope. So that's the equation. Try it with this point and slope and see if you can come up with the right equation. Okay, so we are using point slope form because we have a point and the slope, and the point slope form is y minus y1 equals m parentheses x minus x1. Okay, so what do? We are replacing these values. We're replacing y1, x1, and the slope. So we will write y minus, and what I'm going to do is put parentheses here to plug in the number, okay, equals m parentheses, but I'm going to actually put brackets because we have x minus whatever goes in there, and since we have parentheses inside, that's what we've got. So now let's write the values in. Okay, the slope is 2/3, so we're going to put that there where slope goes, where m is. And the point is 8 comma negative 4. So the 8 goes where the x1 was, and the negative 4 goes where the y1 was. And when we resolve this, it becomes, as a final equation, y minus negative 4 means plus 4 equals 2/3. We got to keep the parentheses here, x minus 8. And that is our equation for the line, or an equation for that line that goes through 0.8 comma negative 4 and has a slope of 2/3. Why is it an equation and not the equation? Because we could use a different point and, we could use a different point and it would come up with a slightly different set of numbers here that would be equivalent, which we'll get to showing that in a minute. Okay, so what is the graph of this equation? Well, again, as I said, sorry for all the noise in the background. As I said, we can find out what the point was that was used by doing the opposite of what we see. We see -2 there, so that must have been a 2 for the x coordinate of the point they used. We see a -1 here, so the opposite of that is 1, and that must have been the y coordinate. So that was the point that they used, because we always need a point to start at, and then from that point, we can rise and run. Okay, so from there, if we go to 2 comma 1, sorry, I'm trying to put that comma in better, then we can start at 2 comma 1, put a point, rise 2, run 3, and put another point, and this is what you see here, okay? The equation is in this form, so the point is 2 comma 1. Go to 2 comma 1, put a point there. That's our first point. We rise 2, run 3. We've got our second point. Now that we have 2 points, we connect them, and we've graphed our line. Okay, so here's your got it problem. First, identify what the point is, and we will graph it in just a second. Okay, so the first thing we need to do is identify what is the point that we are starting at. What point did they use in the point slope form? Well, here if we have -4 after x, that means that it was a +4 for the x coordinate. And here if we have a +7 after y, that means it was a -7 for the y coordinate, okay? Now that point happens to be here at what I marked, 4 comma negative 7. That's that point right here. Now watch this particular fact because this is relevant. Now notice this. We have a slope of negative 4/5. That means if we are already on the line, we know this point is on the line, we pulled that point out from here, and that would only be true if we were using a point on the line. So we can say that's on the line. Now, what do we rise and run in order to get to another point? Because if we have a second point, then we're good to go. Well, we rise, the slope is negative 4/5. So if I wrote it over here as negative 4/5, you can see that we were supposed to rise negative 4. But watch, when I do that, I'm actually off the graph. I can drop -1, -2, -3, but now I'm guessing, okay? And we don't want it to be a guess, so we can't be off of our graph. So what can I do instead? Well, notice this. Negative 4/5 just means you have a negative of 4/5. We could put the 4 on top, and we could actually make the negative be on the bottom. Why is that relevant? Because then from here, we can say, okay, now we've got a rise that's positive, 1, 2, 3, 4, and a run that's negative. Okay, so we rise 4, 1, 2, 3, 4, and then we run in the negative direction, and that's going backwards. That's this 1, 2, 3, 4, 5, and now we get another point that is also on our line. And you could see that, okay, if we then from there did our original rise and run, our original rise of -4, drop 4, and a run of 5, we would be back to another point. So these are equivalent ways of doing it. Now what do? We connect them with a line, and let me get my line tool. Of course, putting arrows because that goes on for forever in both directions. And so that becomes the graph of this equation. How did we do it? We first identified what point, and that says -4, so we had x was 4. That says +7, so x was -7. 4 comma -7 is our first point, and then we rise and run whatever the slope says. The negative can be either on top or on the bottom, depending on what we want to do. I put it on the bottom so that we could rise 4, run -5. We had 2 points and connected them. Okay, so up at the top here, you notice that it says we can write an equation of a line given any 2 points, but first we're going to use the 2 points to find the slope, and then we will use one of the points in order to write the equation in point slope form. So let's say this point on the top here is point number 1, so we've got x1 and y1, and here we've got x2 and y2. Okay, so that when we write this equation, we are using the slope formula, m equals y2 minus y1 over x2 minus x1. What is y2? Y2 is -3, so that goes first, minus what is y1? Y1 is 4. -3 minus 4. Over x2, what is x2? -2, so that's there, minus x1, 1. And when we do this, we get 2 negatives, so we simplify that into just positive 7/3. That's what our slope is going to be here. Okay, so we say 7/3 here. And then what do we use for x1 and y1? Well, we can just use this first point, but either point would work. So we say for x1, we put it there, the 1, y1, we put the 4 there, and that becomes the equation of our line. Okay, so you're going to do this got a problem. What if we used, and this is cool to do, okay, we already know that the slope is going to be the same no matter what, but what if we use the point -2 comma -3 instead of 1 comma 4 to write an equation? What would that equation look like if instead of substituting x1 and y1 with 1 comma 4, you substituted it with -2 comma -3? And then also, we're going to take both of these equations and we're going to rewrite them and see what we get when we compare the two equations when we rewrite them in the slope-intercept form. Okay, so let's try that first by doing this first part. Okay, so what we would do is we would say, okay, we're going to take y minus y1 equals m parentheses x minus x1. And what do we put in for y1? Well, now for y1, we're going to be using -3. The slope is still the same, 7/3. Okay, but now we're going to be putting in, for x1, we're going to be putting in -2. Oops. And when we resolve that, we get the equation y plus 3 equals 7/3 x plus 2. Remember, subtracting a negative makes it a positive. Subtracting a negative makes it a positive. Okay? Now, are these equations for the same line? Well, I'm going to take this, and I'm going to write it on the next page. This equation here and this equation that we just came up with, and we're going to convert them into slope-intercept form. And we'll examine the results in just a second. Okay, so what does it look like to convert to slope-intercept form? Because there's only one way to write an equation of a line in slope-intercept form. So we're going to try and get it into this form, y equals mx plus b, okay? And how do we do that? Well, we first distribute here. So we're going to distribute this through to both things here and here, and I'm going to do it over here simultaneously, okay? We're going to distribute this here and here. So what we get then is, on this one, is y minus 4 equals 7/3 x minus, and 7/3 times 1 is 7/3 minus 7/3, okay? Over here, we are going to say y plus 3 equals, you get 7/3 times x is 7/3 x. And what is 7/3 plus 2? It is, I'm sorry, 7/3 times 2, it is 14/3. Okay? Now, just for the ease of this for me, I'm going to convert these improper fractions here and here into actual mixed numbers. So I say that's the same as y minus 4 equals 7/3 x minus 2 and 1/3. And for this one on the right, we're going to say that's y plus 3 equals 7/3 x plus 3 goes into 14 4 times, 4 and 2/3. Okay? And now what do I need to do to both sides? Well, I need to get it to say y equals. And right now it says y minus 4 on the left-hand side, so I'm going to add 4 to both sides. Okay? And this is a little bit of tricky math when you're adding opposite sign fractions. Okay, but the way that I look at it is, for this is 2 1/3 units below 0. So if I took the first 2 1/3 units of this to get to 0, what would be left would be another 1 2/3. Okay, and that's in the right form where you can see that this is the slope and this is the y-intercept. Now let's do it over here. We have to subtract 3 from both sides. And what do we have then? We have y equals 7/3 x. And here, if we've already got 4 and 2/3 and we're only taking away 3, we're not going into the negatives. We now just have 3 less than we had before, or 1 and 2/3. And when you examine those two, you see that they are exactly the same equation. What that means is that no matter which point you use in point-slope form, it will convert in slope-intercept form to the exact same equation, and you always are describing the same line regardless of which point you're using in point-slope form. So here you have a table which describes the descent of a hot air balloon, okay? After time in seconds, let's see what it says. The table shows the altitude of a hot air balloon during its linear descent. And the descent could be straight down, even though the line is sloped. The balloon could be coming straight down over time, because if you were to then make a graph to get these values, you would say this would be the time, right? Not the horizontal movement across the ground, but just the time. So as time is moving forward, like this, the balloon is dropping like that, but it could be just dropping like that over time. Okay. Anyhow, that's just worth pointing out because some people confuse what the graph looks like with the path of the balloon, and that's not necessarily the case. Okay, but what do we got? Well, what equation in slope-intercept form? Slope-intercept form, notice what they're asking for. They want it to convert it into y equals mx plus b. Gives the balloon's altitude at any time. Okay, and what do the slope and the y-intercept represent? So that's an important part of this. So what do we do? Well, how does the table help you? We have 4 points. We can pick any 2 of them and find the slope with it. So what they're going to pick in this particular case, as you see, is they pick this point, 10, 640, and 30, 590. And if we assume that's s in seconds, I'm guessing that's what it means, then, right, after 10 seconds, it was that high above the ground. After 30 seconds, it was lower because it's descending. So how do we do that? Okay, we use the slope formula to find that the slope is negative 2.5, meaning that the balloon is dropping. And now we use that slope and one of the points. They use this point, 10, 640. So they put that in for x minus x1 or x minus 10, and y minus y1 or y minus 640. So this becomes your equation, and now you convert it to slope-intercept form. How do they do that? They distribute this through. Negative 2.5 times x is negative 2.5x. Negative 2.5 times negative 10 is positive 25. And that positive 25, when you then add 640 to both sides, becomes 665. Okay? And that is the equation in slope-intercept form. Okay, what does it mean? What does it stand for? Okay, the slope of negative 2.5 represents the rate of descent in meters, because that's the y-coordinate, is meters, per second. And the y-intercept of 665 represents the initial altitude of the balloon in meters when it started descending. So at time 0, it was 665 meters above the ground. And that's going to be a consistent thing, is that the y-intercept is whatever the y-coordinate is when x is 0, because on the y-axis, x is always 0. So you're going to do this same thing now here. It says the table shows the number of gallons of water, y, in a tank after x hours. Okay, as the number of hours increases, the number of gallons of water increases. That suggests that the tank is filling. Right? As time gets higher, so does the amount of water in the tank. The relationship is linear. What is an equation in point slope form that models the data? Point slope form, they wanted in y minus y1 equals m parentheses x minus x1 form. What does the slope represent? Okay, so that's what we will calculate. And then write the equation into slope-intercept form. And what does the y-intercept represent? Let's do this now, come back and check our answers. Okay, so what is an equation in point slope form that models the data, and what does the slope represent? I picked these 2 points. You can pick any 2 points that you want. I picked those 2 particular points. If it's point 1, that's x1 and y1. If this is the second point, that's x2 and y2. And so over here, where we have y2 minus y1 over x2 minus x1, I do y2. You can verify the values over here that I'm using and plug them in, simplify it out, and I get eventually this right here, 1,250 over 1, which, by the way, what is this number on top? What is the y coordinate? That's the number of gallons. So if I write that as gallons, and this on the bottom is hours, then what we get as a slope is we have it filling at 1,250 gallons per hour. For every 1 hour, it's filling at that, right? Now, what is the equation in point slope form? Well, that is point slope form here. And so if I plug in the numbers for the slope and for one of the coordinates, which I picked at point number 1, we get this here as an equation. Okay, and I'll just circle that as the point slope form of the equation, or a point slope form of the equation, because we could use different points and get different equations in point slope form. But when we put it into slope intercept form by first distributing here, distributing there, and then adding this amount to both sides, we get this in slope intercept form, which would be the same every time. Okay, so what does the y-intercept represent? This right here. It represents, as we started filling, if you put in a 0 here for x, time was 0. That part goes away, and you get y, the number of gallons in the tank at time 0 was this number. There was 820 gallons of water in the tank at time 0 when we started filling it at this rate. Okay. This is all stuff that you can get very familiar at, but you're gonna need practice. Do not shortcut the practice on this particular unit. A lot of people do. They find it to be difficult, and instead of saying, oh, if something's difficult, I need to spend more time on it, they say it's difficult, I'm gonna run away from it, and then everything else is more difficult. This is gonna come up again in geometry. It's gonna come up again in Algebra 2, and assuming you go beyond Algebra 2, it will keep coming up. So you can either learn it now and be good at it every time you see it and be confident and strong in the math and understand what's going on and score well, or you can try and ignore it by not putting in the time now, and then you'll keep running into it and keep having difficulty, keep scoring low. So it's worth it for you to invest time now. This lesson check set, I don't have the solutions easily. I mean, I can calculate them all, but I will repost this video once I get access to the teacher edition, and I can neatly post all of the answers in a nice clear set. Anyway, hope you understood that. Definitely be asking questions and definitely be signing up for office hours to work with me and do your practice, 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 practice. Okay, good luck.